All right, we've made it to parametric equations. Next is going to be polar. Hey, it's been a long semester. You've put in a lot of work. I hope you can take a big sigh of relief because I think we're into stuff that's not the worst. This is, if you could do the stuff in the past, I think you're going to do great with this. Just got to put in a little bit of time and we should get it. Now, this stuff here, you're going to use, if you're moving to Calc 3, you're going to need to know stuff about parametric equations. So we're just getting you prepped right now, getting you ready. And our next section is polar, and we're getting you ready for Calc 3 once again. So if this is your last class in calculus, congratulations. But we get to do a little bit more. Okay. Now there's some really good applications to this. So let's just kind of jump into the problem that we're going to start with, just so we can kind of see what's happening. What is a parametric equation? Well, an application or a way we can think about this is we could say like our x is defined by time. So when we see a graph, typically, this is not our graph, but just a graph, maybe the graph looks like this. And then we look at this graph and we're like, yep, there it is. There it is. It's not moving, it's static. It's not moving. We can't see what's going on. But with a parametric equations, we can start to see which direction something is moving with respect to time, right? Because you live in a world where there's time, right? You watch things pass you by. You're sitting on a street corner. You can watch the cars drive past. You can put it into your own X, Y, comma, Z piece, and you can see as things move throughout time. So this is going to become some sort, I'll tell you right now, it's going to be a parabola on its side. But we're going to start talking about the direction the values go as we move through time. Let's get after it. Let's get after it. So we're going to do this the long way. And then we're going to do this in a much shorter way. We'll learn something. So let's go the long way first. So we can see that x is defined by the value of t. We can see that y is defined by the value of t. So we're going to go back old school. You remember like when you first learned how to graph? They make you do a table and you'd plot all the points. Well, let's say t. And then we'll have x. We'll plug it in and then we're going to have y. Not that big of a deal. Now typically, when does time start? Typically. Time starts at 0, but let's start back a little bit. I don't know. Let's just put in some values of t. Let's start at -2, then let's go to -1. Let's go to 0, 1, 2, and I don't know. Let's go up to 3. Nah, I want to go to 4. I don't know. I'm just feeling weird today. You know what I mean? Cool. Now let's start popping things in. Now, hopefully I don't make too much of a mistake here. So we're going to put in for x, now we want to put in our -2. So that's going to be equal to something squared minus 2 times something, and that's going to become -2. So we get 4 plus 4, we get 8. Cool. And we're going to get some sort of x comma y. I mean, you could just draw another one over on the side and be like x comma y. What's our points we're about to plot? That's up to you. You can do that if you like. So we got our 8, and now we're just going to keep running through it. We're going to do it for -1, and I'm just going to start popping in the numbers so you don't have to watch me put in -1 and -1. We're just popping them into x. Now we're going to put in 0. That's got to be 0 squared minus 2 times 0. That's just 0. We move down to +1, and we're going to get 1 minus 2, which is -1. We pop in 2. We get 0 once again, right? 2 squared minus 2 times 2. 3 will give us 3, and 4 will give us 8. Super cool, right? We're just plugging in numbers. But man, there's got to be a better way, right? How silly would that be to have to pop in a t for every value? But it's all good. Let's just keep going. So now we're going to put in t equals -2 into our y values. So we get y is equal to -2 plus 1. That's -1. Y equals -1 plus 1. That's 0. Sorry, this one's quicker. I can just do it. 0 plus 1. That one's 1. 1 plus 1. Well, you could see. Aren't we just getting bigger by 1? It just says, hey, take your t value and add 1 to it. So now we have plotted points. And we can take a look at them, right? 0, 1, -1, 2. Isn't this kind of nice? I know it's long and it's tedious, but in comparison to what you're doing, we are literally plotting points. So now that we have it, oops, I erased the wrong thing. We can now graph. We can see what's going on. So that's the part where it says sketch the curve. And then next we're going to identify the curve. So let's not make this perfect. Make that 8. Let's make this 3. Let's make this 0. And then we got a -1 over here. Not to scale. But it looks like all of our y values, they start -1 and they're just going to go up 1, 2, 3, 4, and 5. Okay, not perfect, but let's start plotting some points. So the first one is 8, -1. So we start down here. Sorry, got rid of my little 8. And then 3, 0. And then 0, 1. And then -1, 2. Then 3, 0. Then 3, 4. And then 8, 5. So when we look at this, but let's think about it in this manner. Actually, I should draw it in a different color. Let's make these all green. We're going to follow time. It's going to matter. It's not just the graph. We're moving this way through time. So we start here, and we're going in this direction. And yeah, it makes a, wow. Hold on, let me try that one more time. Graphing is not my strong suit. Make the dot bigger. Look at that, I made the dot. But now we can see it's traveling through this path. We can see the path in which it's going. It's a parametric equation that can describe the movement of an object throughout time. That's powerful. That's applicable. We could do something with that. Now look at my crappy graph. Now that's a terrible way of doing things. I think that's too much work. Just like trying to graph a parabola or something typically from back in algebra. Plotting points is ridiculous. So let's do it this way. Let's get rid of all of our t's. So this is the second way. We've already sketched. We sketched the curve. But we could have done this in a quicker way. So let's see what we can do instead. So let's take these two off to the side. And we're just going to do what's called the substitution method. You've done the substitution method before in algebra. We want to, here we go, we're going to remove the t's. So we look at this and we're like, which one would be easier to solve for t? This one with the x or the one with the y? Yeah, of course, the one with the y is going to be simpler. So let's just subtract 1. So t, right, subtract 1 is equal to y minus 1. Now we've solved for t. See it? See? T equals y minus 1. And look at these t's right here. There it is. So a little substitution method. So now we can replace our x, and anywhere we see a t, let's just make ourselves a parenthesis. And then we're going to take our y minus 1 and pop it on in. Here we go. Let's expand that out. I'm going to assume everybody knows how to expand that. That's y squared minus 2y plus 1. Now let's bring our negatives in. So we get negative 2y plus 2. Now let's combine some like terms, and we see that x is equal to y squared minus 4y plus 3. We've now, we've removed the parameter. We've gotten rid of it. So we can now see that we have a parabola on its side. And hopefully by this point in time, we know what a parabola on its side would look like, right? If it was y equals x squared minus 4x plus 3, you could graph this thing like such and go, and then it would be a parabola facing up, right? It'd be going up, like this. But now, since we have everything flipped with x's and y's, it's a parabola on its side. Not a function, but it doesn't need to be a function. So we have figured out what the heck it is. So we're going to spend more time in our next videos going to this step first and then doing our graphing. But when we do graphing, we need the arrows. We need to see what direction it's traveling over time. So I think that is probably good enough. I know most of y'all are burnt out right now. We're towards the end of the semester. You've been working hard. There's stress. You got a few more weeks. Let's grind through this thing. Let's finish strong. Let's feel proud of our efforts so then we can go and take a nice long vacation and come back at it later. All right. See ya.